You know, every system out there, the acoustics in a room, the shocks in your car, even a simple photo filter, it's got a secret personality, a hidden character that dictates exactly how it's going to behave. But what if I told you we could uncover that entire personality just by giving it one single perfect poke? Yeah, you heard me. Let's get into it.
No, really, think about it for a second. The number of songs you could play in a concert hall, or the number of different bumps in a road, it's literally infinite. So how on earth could we ever hope to predict how a system will react to all of them? It sounds completely impossible. You can't just test every single input, right? Well, it turns out that for a huge and really important class of systems, you don't have to. All the information you need, the system's entire character, can be revealed with just one simple test. It's like the ultimate cheat code. So let's call this the system poke test. And the idea is just so beautifully simple. All we're going to do is hit the system with a perfect, instantaneous poke. And then we just watch. We listen, we see exactly what it does in response. And that reaction, that's its signature. That's its fingerprint. Okay, so in the official language of signals and systems, our poke is called a unit impulse. And the system's reaction to it is called its impulse response. We usually just label it H. And here is the mind-blowing part. This single response contains everything you need to know. It's basically the system's DNA. But there's a catch. This little magic trick only works if the system plays by two very specific rules. And those properties are linearity and time invariance, or LTI for short. So linearity just means the system plays fair. The response you get from two inputs added together is just the sum of the responses you'd get from each one individually. Simple enough. And time invariance? Even easier. It means the system doesn't change its behavior over time. If you poke it today, you get a response. If you poke it tomorrow, you get the exact same response, just shifted to tomorrow. These two rules are the absolute foundation for everything we're about to do.
Okay, so we know how an LTI system responds to a single, simple poke. Great. But what does that have to do with a complex input, like a whole song or a detailed photograph? Well, this is the next key insight. Any signal, no matter how complicated, can be seen as just a long sequence of these simple pokes. Think of it like building with Lego bricks. Each Lego brick is a unit impulse, one of our pokes. To build your big, complex signal, you just move along in time, and at every single moment, you place a Lego brick. The height of that brick is just the signal's value right at that point in time. When you step back, you see that any signal, we'll call it x of n, is really just a sum of a bunch of scaled and shifted impulses. Every complex input is secretly built from simple pokes. And this is where it all clicks. The source material says it perfectly. Since our input is just a sum of all those Lego brick pokes, and since our system is linear, the output has to be the sum of the responses to each of those individual pokes. The system just responds to each little piece of the input one by one, and the final output is just all those tiny responses added up together. So we have our input signal broken down into pokes, and we have our system's character, its impulse response. The process for actually combining them to predict the output has a special name, convolution. Now, it sounds a little intimidating, but trust me, it's really just a recipe. And this is the recipe in mathematical form. Think of it this way. Your input signal, x, is that series of pokes. Every single poke that goes in triggers an echo of the system's impulse response, h. So to figure out what the output is at any single point in time, y of n, you just add up all the echoes from all the past pokes that are still ringing out at that very moment. The final output is just the beautiful mess of all these overlapping echoes. Now, there's a really cool visual way to do this called the flip and slide method. You start with your two ingredients, the input x and the impulse response h. First, you take that impulse response h and you literally flip it backward in time. Then, you start sliding this flipped response across your input signal. At every single position you slide it to, you multiply the parts that overlap and add all those products together. That sum gives you exactly 1 point of your final output. You just keep sliding and repeating, and before you know it, you've performed convolution. So now we've got the tool to predict any output. But what can the impulse response, h, tell us just by looking at it? Well, it turns out it reveals a system's deepest personality traits. For instance, is the system causal? Just check if its impulse response is 0 for all time before the poke at time 0. Which, yeah, that makes sense. A system can't react to something before it happens. Is the system stable? Well, if the impulse response eventually fizzles out and dies down, then yes. It means a small poke won't cause the system to shake itself apart and explode. The response is contained. And is it memoryless? A system is memoryless if its response is just one single instant blip at the moment of the poke and nothing else. It means the output right now only cares about the input right now, with no memory of the past.
And this is the crucial point. This whole framework, seeing signals as pokes and systems by their signature response, this isn't just some clever academic trick. It is an absolute superpower, and that is why it is fundamental to so many fields. And this stuff is everywhere. The reverb you hear in a cathedral, that's literally the impulse response of the room. A blur effect on a photo, that's just convolving the image with a blur poke. Moving averages in stock charts, edge detection for computer vision, filtering noise out of a phone call, even your car's cruise control. It all comes back to LTI systems and convolution.
So let's just let that sink in. We started with what seemed like an impossible problem. How do you test for an infinite number of inputs? And we found that for LTI systems, the answer is stunningly simple. You find its one true signature, the impulse response. And suddenly, you hold the keys to the kingdom. You can predict its behavior forever. And that brings us to a final really cool thought. So far, we've talked about analyzing systems that already exist. But what happens when we flip the script? If the impulse response is a system's DNA, a blueprint for its behavior, what kind of incredible systems could we build by designing that DNA from scratch? What kinds of filters, effects, and controllers could we create just by writing the perfect impulse response? Well, that's where engineering becomes an art form.